Okay, so let's look at this example number 5, which is obtained from example 9.3 in textbook. Okay, so the state of stress at a point just before failure of this shaft is shown in figure. Represent this state of stress in terms of its principal stress. So your main goal is to find what is sigma 1, what is sigma 2, and also what is the theta p. Okay, what is the angle that caused theta 1 and theta 2 to happen? Okay, so you have to determine these three unknowns. Okay, so it is given this element. Okay, and then this element is having negative 20 megapascal of normal stress in x-axis, and we have positive 90 megapascal for normal stress in y-axis, and also we have positive 60 megapascal for shear stress in xy plane. Okay, so this is the solution. Okay, so we have sigma x, sigma y, and tau xy given in the question. Okay, so first you have to determine what is the orientation of principal planes. To do this, you can use the equation number 4, which is tangent to theta p is equals to tau xy divided by sigma x minus sigma y over 2. Okay, so you just need to substitute all of this information into this equation. Okay, and then so this is the ones you already substitute the data information, and then let's say the first term you get is 2 theta p2. Okay, and then it is equals to negative 47.46 degree. Okay, next is to find what is theta p2. You just need to divide it by 2, so you will get negative 23.7 degree. So that's mean in this plane it is acting clockwise. Okay, and then once you already have the theta p2 value, so you need to find what is theta p1 value. Okay, so as I mentioned in previous slide, theta p2 to theta p2 must be 180 degree apart from 2 theta p1. Okay, so 2 theta p1 is equals to 180 degree plus 2 theta p2, which is you already found it here. So substitute it here, and then you will get 132.51 degree. And same here, you divide by 2, you will get theta p1 is equals to 66.3 degree. Okay, so now we already know what is the value for theta p1 and theta p2 and theta p1. Okay, next is to calculate what is the principal stress. Okay, so you want to calculate what is the maximum normal stress and also minimum normal stress. Okay, so you can use equation number 5, which is this equation. Okay, just substitute all the informations given in the question, so you can get equals to 35 plus minus 81.4. Okay, so sigma 1 is equals to 35 plus 81.4, so you will get 160 megapascal. And then for sigma number 2, so it is 35 minus, okay, minus 81.4, so you will get negative 46.4 megapascal. Okay, in previous slide you already defined what is theta p1 and theta p2, and then sigma 1 and sigma 2. Okay, so now you cannot just simply say that this sigma 1 is acting at this plane which having theta p1, and also you cannot simply said that sigma 2 is acting on the plane which having theta p2. Okay, so to make sure that, to determine in which plane that the principal stress is x, okay, so we can use equation 1 again and substitute the value of angle. Okay, so this is the equation number 1. Okay, so let's say for example we use theta p2 is equals to negative 23.7. okay, we use this 23.7 and then substitute into this theta value, and then you will get, okay, so sigma x and sigma y also tau xy, we just need to substitute the value that obtained from the question that given from this question. Okay, so substitute theta is equals to negative 23.7 here and also here, so you will get negative 46.4 megapascal. So that's mean at the plane which having theta p2 equals to negative 23.7 degree, the maximum of the maximum of stress is negative 46.4 megapascal. Okay, and then on another plane which is at the plane defined by theta p1 equals to 66.3, so the sigma value is 116 megapascal. Okay, so to check this one, you can also again use this equation and then you substitute this value, okay, which is 66.3, and then you will get sigma x is equals to 116 megapascal. Okay, so as you can see in this figure, so you can see that the element, okay, so this element is rotated clockwise at angle of 23.7 degree, and the maximum in plane's normal stress here is equals to 46.4 megapascal. Okay, so since the value that you obtain here is negative, so it must acting inwards. Okay, and then for another plane is, which is here, so this is x axis and this is x prime axis. Okay, so the plane is rotated about 66.3 degree counterclockwise. Okay, so counterclockwise, and the maximum normal stress, the maximum in plane normal stress here is equals to 116 megapascal. Okay, so here you also can see that theta p2 and theta p1 is 90 degree apart. Okay, so 90 degree apart, and also here, when you get a principal stress, there will be no shear stress acting on the element. Okay,